Hello, I'm Mark Shaw. I work for GE Additive. My career is really a long-time GE employee working primarily for GE Aviation. So I was a jet engine parts designer for something like 30 years. I won't tell you exactly how many. In the past decade, I've been working additive manufacturing. It started with the re-engineering of the narrow body market for aviation. There was a particular part, it's called a fuel nozzle, that I was the design leader for, and it very quickly ran into some technical challenges for which additive manufacturing created a solution. It really was the first endeavor to use metal additive manufacturing in an application that required FAA airworthiness approval. So that approval was in 2015, I believe. And so since that time, we've been taking sort of that knowledge and learning forward. Today, GE's products have hundreds of additive manufacturing parts, and these are commercial and military products. Today, GE has created a business outside of GE Aviation, so we sell more than jet engines these days. We sell additive manufacturing technology to third parties. That includes automotive, medical, space, and of course the aviation world as well. My role today is I am the Director of Government Programs for additive manufacturing. So most of my days I'm talking to Army, Navy, Air Force. But really for me, it's very exciting to talk about metal additive in use in some of our most critical applications. Yeah, fantastic question here. So as I said, I've been involved with additive manufacturing for something like 10 years, but it's really only in the last 5 to 7 years that it's really become a topic of great interest as we talk about Industry 3.0 or Industry 4.0 and understand why do we care about modernizing our factories. You know, I think about DoD and the space that I spend most of my time, or you know, just space in general. For us to maintain, for the U.S. to maintain a leadership position, or really for whatever countries to maintain a leadership position, we really need to embrace these next generation technologies that are really allowing us to manufacture parts in a way that they perform in ways they could never previously perform at cost points that are much more favorable, and then also do it in a way that's environmentally friendly. Yep, good question again. And for me, I'm a little bit of I've been in this space for, like I said, a decade, and it really, the answer to that probably for me hasn't changed a whole lot over the last 5 years, but it really is about this idea that I'm using metal additive in flight critical applications. You know, whether that be a jet engine, whether that be a flying airframe on a military engine, or that's a vehicle going to space, you know, whether traditional space or even into hypersonics. Additive manufacturing is playing a role today and will continue to grow. But one of the most interesting challenges for me as an engineer is to talk about how we can make sure that it's safe and it's repeatable and we understand its performance so that we can use them in these most critical applications. Yeah, so I'm very much looking forward to spending more time thinking and talking about people who are experts in the area of space. I'm primarily, I started my work in the commercial aviation industry, so like next generation narrow body, for instance. And then most recently now with the Department of Defense, so next generation warfighter aircraft type of things. And so I do talk to the space folks now and then, but for me, it's very interesting because there is so much intersection between those areas that I'm actually interested to learn from folks that I meet at SpaceX as well.